Alright guys, so these are the factoring notes for today. And I already said what we're going to be doing. We're going to be factoring. So the first thing, factoring can be thought of as the opposite or undoing of multiplication. Before any factoring problem, we first have to look for a greatest common factor. Can one singular thing be pulled out of all of the other things? So let's take a look at this first example. It says factor the following problems by taking out a GCF. So if we're looking at the first term, there's 3x cubed, and then the second term has a 6x. So what is coming out of both of those things? Okay, in here we have a 3. Inside of this 6, there's also a 3, so we could pull a 3 out of both of them. And remember when we would do that, we would divide each term by 3 and move it to the front. Okay. From here, you can see that there's 3 x's. This is x times x times x, and then there's 1 x here. So it looks like we could pull an x out of this one and an x out of this one. And we would do the same thing. It would just be like pulling it to the front. Okay? So we have 3x cubed minus 6x. So a 3 comes out of both of those. And an x also comes out of both of those. So then what we'd have left would be x squared minus 2. Okay, and how did that work? That was 3x cubed divided by 3x. So the x cubed here would cancel and we'd be left with squared. 3's would cancel, and then we would just be left with x squared. For our second term, we would have 6x divided by 3x. X's would cancel, and we would just be left with 2. Okay, so when we pull out that 3x, it's like dividing each term by that 3x. So then this would be our final answer. Okay, let's take a look at the next one. In the next term, just factoring a greatest common factor here, we have 10, 2, and 12. X does not resonate in all three, so we can't pull out an x. But it looks like 2 would come out of both of those, so we divide each of these by 2. So it's going to be 2 times 5x squared minus x plus 6. And that would be our answer for pulling out the greatest common factor. And then finally for 15 and 5, so that means a 5 is going to come out of both of them. X squared and x tells us that an x would come out of both of them, and we have 3x minus 1. Okay, and that's what pulling out the greatest common factor would look like. Next, before we actually start doing some serious factoring, let's talk about foiling to bring us back. So foiling, if you don't remember, stands for first, outside, inside, and then the L stands for last. So that's what foiling is. So then let's go through this. So the first two terms would be the x's. That would give us the x squared. The outside terms would be x and negative 5, which gives us this negative 5x. The inside terms would be the 2 and the x, which would give us this positive 2x when we multiply them together. And then the last terms would be 2 and negative 5, which would give us that negative 10. Okay. From here, we have to combine the negative 5x with the positive 2x to get us this negative 3x in the middle. Okay, and that's how we would FOIL. So then let's kind of just roll through this real fast, because hopefully we've done a lot of foiling. X times x gives us x squared. X times 2 gives us plus 2x. Negative 7 times x gives us negative 7x. And then negative 7 times 2 gives us negative 14. Combine the like terms, we get x squared minus 5x minus 14. Okay, number 4, same idea, right? X times x is x squared. Negative 4x, negative 3x, positive 12. Negative 3, negative 4 becomes negative 7x, so we have x squared minus 7x plus 12. And then the last one here, x times x is x squared, x times 6 is positive 6x, 1 times x is positive x, and then 1 times 6 is positive 6, so we get x squared plus 7x plus 6. So, I know we went through those fast, but hopefully you're noticing something. The last term that we get, here I'll circle the positive, the last term that we get is always the two terms at the end being multiplied together. okay? The middle term that we get, so notice this negative 7x here, is actually just negative 3 plus negative 4. That would give us negative 7, okay? And then it just has an x on it. So you add the two terms in the end to get the middle term. You multiply the two terms at the end to get the last term. That's going to be helpful for when we start doing some actual factoring. So let's take a look at these factoring questions right down here below. Whenever we start factoring, it's going to be super important to be able to figure out what the multiples of some numbers are. So for instance, in this first one, because the last term is always the two terms at the end of our factors multiplied together, we would need to figure out, well, what are all the multiples of 28? So if we're going through 28, we have 1 and 28, we have 2 and 14, we have 4 and 7, and then that's going to be it. So once we have all those factors, this is helpful because two sets of these factors have to add together to give us the middle term. Okay? Because the end term we multiply them, the middle term we add them. Okay? So, a couple other helpful hints here. You always want to look at this sign at the end. The sign at the end tells us what is going on in the middle. If it's a positive number at the end, inside of our parentheses of the factors, we're going to have matching signs. Okay? What do they match to? They match to the middle sign here. So because it's positive, positive means matching. Okay? And then they match to the sign in the middle. So that means each of these is going to be a positive. Okay? From here, we look at our factors, 7 and 4, 14, 2, 28 and 1. We look at the two factors that are going to add together to get 11. So it looks like 7 plus 4 would give us 11. So then if we fill this in, we get 7, we get 4. And then the very first term in the front here, x, is always just going to be what's in the front. So x times x would give us x squared. Okay? So now we can double check, right? X times x should give us this x squared. 7x and 4x should give us 11x, and then 7 times 4 should give us 28. Okay? So if I asked you to factor x squared plus 11x plus 28, you should get out this answer. Okay? So let's take a look at the next one. X squared plus x minus 2. So this minus right here tells us that the signs are opposite in the middle. So signs opposite. So when we build our factors, we're going to have a factor here, a factor here. The signs are going to be opposite. One's going to be plus, the other is going to be minus. Okay? The nice part about 2 is that there's only one option. Okay? You have 1 and 2. Those are the only options for factors of 2. So 1 and 2. We need a positive 1 in the middle. So we need to go bigger number with the positive, positive 2. Smaller number with the negative, negative 1. And then x and x in the front. The reason being is because 2 plus negative 1 is going to give us out this positive 1 right here. Okay? So then that would be our answer. Right here, x plus 2 times x minus 1. So hopefully you're starting to see a little bit of how I'm working through these questions for factoring. So we have positive 9 at the end. That means our signs are going to match. What are they going to match to? They're going to match to the negative in the middle. So that means they're both negative. Okay. 9 doesn't have a lot of factors. We have 1 and 9. We have 3 and 3. Well, we need negative 6 in the middle. Okay. So 3 and 3 would give us 6. And because they're both negative, that should give us our negative 6. So negative 3, x and x. Alrighty, let's take a look at the next one. Negative in the end tells us that the signs are opposite of each other, so negative and positive. 14, okay, so we have 1, 14, 2, 7. Looks like we can stop there, right? Because 2 and 7 can make 5. So we have negative 7, because it's a negative here. and we're going to have positive 2. That would give us that negative 5. Then we just fill in the x's. And then the last one here, okay, this one, let's take a look at it. Always double check greatest common factor. I know we hadn't been doing that in the top, okay, and that's just because of my memory. I've done those questions too many times. In the bottom here, we have x could come out of all of them, right? We could also pull 2 out of all of them. So if we pull out a 2x, that's going to give us x squared plus 4x plus 3. And now this, I think, should be able to be factored. So then let's keep going. That 2x will always stay in the front. And now we can build our 2 factors. Positive at the end tells us positive and positive in the middle, because positive at the end, positive in the middle. And then we need to build 4. So 3 and 1 would build 4 in the middle. So then we have x and x. And then that would be our answer, right? So this actually has 3 factors. 1, 2, 3. These are all factors of our original polynomial. Okay, so when we pull out a greatest common factor, sometimes there's going to be more than just the 2 factors that we're used to. So let's do a couple more examples together. If you're feeling pretty good, guys, you could skip a little bit ahead to a later portion of this. But I'm going to go through these examples right here. So negative at the end, negative in the middle. Tells us opposite signs. So positive, negative. We need 5 in the middle. Well, 6 has 3 and 2. If we added those, would give us 5. But we have a negative and a positive. So 3 and 2 is not going to work for us because we're not physically adding them together. One is going to subtract from the other. We also have 1 and 6, though. Well, if we made it negative 6, that would give us pretty close to negative 5. But then we're just adding the 1 to it. That would get us to our negative 5. So we have x plus 1, x minus 6. All right, next one. We have positive at the end and then a positive in the middle. So that tells us the signs will match. Okay, positive, positive. 3 only has 1 factor, or 2 factors, 1 and 3. Okay, this one's the easy one. That's nice. Whenever it's a prime number, it's super, super easy. Okay, last one here, 8. We have negative at the end. We have negative in the middle, so positive, negative. This one does look like it's going to utilize 3 and 2 because we need a negative 1. So we're going to go negative 3, positive 2 would give us x and x. Because positive 2 plus negative 3 gives us that negative 1 right here. All right. So hopefully these are starting to look familiar to you because you should have done factoring a lot in your past. But let's keep going. Positive, positive. So that's going to be positive, positive in the middle here. Okay. X squared tells us just x and x. 12 at the end, 7 in the middle. So 1 and 12, 2 and 6, 3 and 4 can stop. 3 and 4 can make 7. So 3 and 4. All right. These last two, you have to factor out a greatest common factor first. X comes out of all of these. And that looks about it. So if we did x out of all of them, that would be x squared minus 2x minus 24. And then we got to factor 24 so that we get a negative 2. Luckily, it's negative, so that's going to give us positive and negative here. Okay, let's think of some factors of 24 that are close to 2. It looks like 6 and 4, right? So if we went negative 6, positive 4, that would give us those. And then we can't forget the x out front. Okay, if you forget that x out front, it's like forgetting one of the factors. Okay, so make sure you bring that down with your answer. And then the last one here, factor out a greatest common factor of here. 3 would come out of all of these. So 3x squared plus 2x. Oh, 372 times 3, what is that? Oh gosh, I'm blanking. 1, no. 2 and 4, 24. Okay. So we got negative 24, positive 2. So it looks like 3 again out front. X and x. Negative 24 this time. So we're still going to have positive and negative. But this time it's a positive 2 in the middle. So it looks like we're just going to flip this. So positive 6, negative 4. So just a flip of our last one. All right, guys, so that is factoring. Our a value in all of these was 1, so the a value is always the first term here. Okay. Continuing on. So the next type of factoring that we have is called a difference of squares. Okay. This is going to be a foiling practice right here to show you where difference of squares comes from. So we have x times x gives us x squared, negative 4 and positive x gives us negative 4x. Positive x and positive 4 gives us positive 4x. And then negative 4 and positive 4 gives us negative 16. As you can see here, middle terms are going to cancel. So we're going to be left with x squared minus 16 if we FOILed it out. What this is called right here is a difference of squares. This is a square, this is a square. This is the easiest type of factoring that we're going to do. Okay? So let's talk about difference of squares factoring. So number 12 right here. Square root, that tells us that x and 7 are what's going in our factors. It's negative in the middle here, positive, negative, every single time. X in the front, 7 in the back. Boom. That's it. Number 13, factor. Square root the front, square root the back, so x and 10. Positive, negative always. X in the front, 10s in the back. Okay, that is literally difference of squares. So easy, right? All right, the next one is called our perfect square trinomials. Okay, so we're going to FOIL this out. So if we have x minus 5 squared, don't just distribute the squared. Okay, that's a huge mistake people make. Instead, write it out, x minus 5, x minus 5. So now we're going to have x squared minus 5x minus 5x plus 25. That gives us x squared minus 10x plus 25. And this right here is called a perfect square trinomial. These factorings are a little bit easier because, as you can see, this is a perfect square at the end. In the middle is the addition of the two things that make up 25, right? 5 and 5 make up 25, and negative 10 would be negative 5 plus negative 5. So that's what's nice about these. Okay, so 121, that's 11 if we square root it. It's positive here, so positive 22. That tells us we're going to have positive, positive. 11s are at the end. X's are in the front. Okay. Whenever we have perfect square trinomials, it's always good to combine these into one thing and just say the answer would be x plus 11 squared. Okay. Let's take a look at the next one. 36. So that tells us 6 is going to be what's going in there. What is the 6? It's negative 6. So we have x minus 6. X minus 6, and then we're going to go x minus 6 squared. Okay, so hopefully perfect square trinomials are also easy. The hard part about them is recognizing that it's a perfect square trinomial, because I'm going to throw in something like this next to something that might look like this, number 10. Okay, so just recognizing the perfect square trinomials is the harder part in these. So this next section, or the last section we're going to look at, are a little bit harder. And the reason they're harder is because this is when our a value is not 1. So all the first terms here, notice the a value is not 1 anymore. That makes these questions basically 2 times harder. Okay, so let's go through these. Let's just talk through them a little bit. So for number 16, a value is not 1, but it's prime. Okay, because it's prime, that makes it a little bit easier. It has to be 2x and x. Okay, we don't have any other options, but 2x times x would give us this 2x squared. From here, we have a negative at the end. Negative at the end means it's either going to be positive and negative, or it's going to be negative and positive. Okay, and then we need a negative 1 in the middle. My factors of 15 are 1 and 15. 3 and 5. Okay. 1 and 15 is going to be a little bit of a stretch, right? Because if we put a 15 here and a 1 here, it's going to be 15 times x. It's going to be negative 1 times 2x, which would give us negative 2x. That is not close to negative 1. A lot of the times, the big term here, 1 and 15, is not going to work. Just because, if you look here, we have a smaller number in the middle. So then our factors need to be a little bit closer. Okay, so if we're thinking here, we need to get to negative 1. We have 5 and 3. That's a difference of 2 right now. But we have something that's going to multiply one of those terms by 2. If we multiply one of these terms by 2, is it possible to add the positive and negative versions together to get negative 1 in the middle? Okay, so think about that. If we multiplied this by 2, it'd give us 6, right? Well, 6 and 5 are only 1 away from each other if one of them's negative. So if we made negative 6, so that would put us a 3 here. You can erase that positive. 2 times 3 gives us negative 6. And then we have 5 here. That would give us positive 5. That should be the right answer, because then we have negative 6, positive 5x. Those two things added together would give us that negative 1. So then we're good right here. Okay, so a little bit more thinking is involved when we're taking a look at factors where the a value is not 1. Okay, so let's take a look at another one. This one right next to it. 2p, nice, prime number. So 2p and p. Also nice, all positive. So we can just automatically put positives in the middle here. We have 3, so we really only have one option, 1 and 3. We need positive 5 in the middle. Okay, so if we multiply one of these values by 2, is it going to give us positive 5 in the middle? Well, if we multiply 2 by 3, that gives us 6, so we're already too big if we add it together. But if we multiply 2 by 1, that would give us 2, so then 2 plus 3 would give us that 5 in the middle. The way to check these, 3 times p is 3p, 2p times 1 is 2p, right? 3p plus 2p gives us 5p. And we're good. All right. Next one over here. So now we're getting a little bit harder. Okay, the reason this is harder is because 18 is not a for 18, 4 is not a prime number. So if we're looking at this 4, we have two options here. We have 2 and 2, we have 1 and 4. Okay, I always like to mess with 2 and 2 first. So let's go 2x and 2x. Okay, we're going to just set this here because I don't remember if it's 2 and 2 or 1 and 4. So 2 and 2. This is just going to be like a lot of guessing and checking in our head, really. We have 1 and 6. We have 2 and 3. We need negative 11 in the middle. Okay, so I'm going to look here first. I like these numbers. They're a little bit easier to work with. So if we did 2 times here, that would give us 4 and 6. Right, but they're going to have to be mismatched, right? One of them is negative, the other is positive, so we can write that in here, positive, negative, because matching on the, or actually they're both negative, sorry. Positive at the end tells us matching, negative in the middle means that they're matching towards the negative. So negative 6 and negative 4 only gives us negative 10, so that's not enough. So 3 and 2 doesn't work, okay? Let's go 6 and 1. That's going to be 12 and 2 when we multiply both of those by 2. So then negative 12, negative 2. Nope, not going to work either. So it's looking like 2 and 2 is not our answer here. So instead, let's go to x and 4x. Negative, negative. Okay, let's see what happens when we do these. Well, if we multiply this by 4, that would give us 8. If we multiply this by 1, that would give us 3. Well, 8 and 3 does give us 11. So let's double check we put the right ones in the right spots. 2 would go here. 3 would go here, right? Because we need that 2 to be multiplied by the 4. So 2 times 4 gives us 8x. And then x and negative 3 would give us negative 3x. Sorry, negative 8x, negative 3x. There's our negative 11. Okay? So that's how you would do one that's not prime. It's really just you have to do a lot of multiplication and adding, okay? And the better you are at multiplying and adding things together, the quicker these questions are going to go. All right? So let's take a look at another one. 11, okay? 11's nice. It's prime. So we have 11u and we have 1u. Negative at the end tells us that our terms are not going to match. So we have 1 and 9, and then we have 3 and 3. So the reason I don't like 3 and 3 is because 3 times 11 would give us 33. That's already way too big to consider 2. Okay, so we can kind of cross that out right away. Now we just need to figure out how 9 and 1 are going to work. Well, if we go positive 1, that would give us 11u. And then if we went negative 9, that would give us negative 9u, which that would give us positive 2. So then we're good. These are our factors right here. And as you do more of these, guys, you're going to notice things get easier because you're just going to start picking better numbers to factor, okay? 14, yay, right? Not prime. 1 and 14, 2 and 7. I like starting with 2 and 7, smaller numbers to multiply together. So let's go 2x, 7x, and then we have negative 3. So 1 and 3, that's nice. That's our only options for the end. Positive 1 in the back. I like 3, and I like it multiplied by 2. So let's go negative 3. That would give us negative 6. Let's go positive 1 would give us positive 7. So negative 6, positive 7 would give us positive x. And then we're good. Okay, so hopefully you'll start to get that good where you can just pick numbers that you're like, this looks like it's going to work. Okay. But sometimes you're going to be stuck on one for a while because you just keep picking numbers that are not working. So just keep at it, guys. These are they start hard and then they get easier once you get better at them. Prime number in the front, so 3x and x, that's great. 12 in the back, so 1, 12, 2, 6, 3, and 4. We need positive 5 here. One's positive, one's negative because of the negative here. Okay, so we need positive 5, let's think. I like 3 and 3 would give us 9. So 3 and 3, that's where I'm kind of leaning right now. So if we did positive 9 and then we subtracted off 4, right, that would give us that 5x in the middle. Okay, so that one might have taken you a couple more tries than just guessing on the first one, okay? But literally, that's just because I've done so many factoring problems, I just know what good guesses are. And it just takes a lot of practice to figure out the good guesses. All right, last two here. Factor a difference of squares when a is not 1. Well, this is still a square, right? 2x squared, you can take the square root of that. So that would give us 2x. Square root of 9 is 3, so that gives us 3. So then we have 2x plus 3 and 2x minus 3. Boom, difference of squares. Difference of squares here gives us 4x and 9. So then we have 4x plus 9, 4x minus 9. So we can also do difference of squares when the a value is not 1. Okay, I know this was a super long notes, guys, but hopefully you could skip around a little bit, or if you did need to get all of them, that's totally cool too. Come with questions, okay? Questions are good here. Maybe different methods of factoring are also good here. So if you have a different method that worked for you, let me know, okay?